If you're using Kubernetes, you're probably aware of the zero downtime features that it ships with out of the box, such as rolling update deployments. In this talk, I want to talk a little bit more about how to achieve real zero downtime. So, what we need to take into consideration, how to test our production readiness of our applications, and just how to make sure that we don't distract or disrupt our users that much when we deploy new versions. My name is Sebastian. I work for this company called IBM, and I do a lot of things with Java, with enterprise Java, and with container technologies such as Kubernetes or Docker. And typically, I am on the enterprise side of things. I help projects, and I just want to share knowledge what is important for enterprise projects, such as those who use container and cloud native technologies. And in this talk, let's talk a little bit about disruptions first. So disruptions, there are planned and unplanned disruptions, and of course, anything that is planned for a planned disruption, such as an upgrade of a version of our underlying technologies of our clusters, should not disrupt our users. And this is what I mostly want to focus on in this talk. And while you are probably aware of some of the production readiness features that Kubernetes ships with, such as liveness and readiness probes, which we all will cover, and especially also if you visit the website of Kubernetes, you will see it always has been created with this production readiness in mind. So it is supposed to be production grade container orchestration. And while we will see that it comes with a few features out of the box, such as controllers that make sure that the target state of our resources is always being met, and some other things that we will look in. I have an example application because I like live demos a lot, and I will show you a lot of stuff running on Kubernetes. And this example application is just a very, very basic Hello World coffee application that uses Quarkus. I use JDK 14 and Quarkus in a recent version to run that. And we will see how we basically, run and execute this on our Kubernetes cluster. So just to get started, I have a Kubernetes cluster. Where do I get one? So there are many ways how to get your hands onto a cluster. I typically use a managed cloud version. I use the IBM Cloud Managed Kubernetes service. Why? Because it includes pretty much always the latest version of Kubernetes. So the IBM Cloud is usually one of the first ones, if not the first cloud to adopt a new Kubernetes version. That's also because IBM is heavily involved in, open source in general, but especially in the Kubernetes project. And it just works here really well. So I have a bunch of clusters actually that I will use. And the first one is, a plain Kubernetes cluster with an Nginx ingress controller that, as you can see right now, is empty. So I just want to deploy my example application here, and I can show you, this Java application will be built into a Docker image. So I have a Docker file here that just specifies how my Quarkus application will be built. I use Java 14 with OpenJ9 JVM flavor, and that is provided by the Adopt OpenJDK initiative, which is my Java of choice. And now this will be deployed by a Kubernetes deployment specification, of course. So I will write some YAML here, and I create a deployment for this coffee shop that basically says, please create one instance that is running here that deploys, of course, this image. All right. I already include as well a readiness probe that just will tell me once my instance is up and running and ready to serve some traffic. So once that is being deployed, I see, okay, actually my coffee shop is ready. And now I could access it from, let's say, outside of the cluster. I can say kubectl nginx IP address. That will just give me that IP address here and say coffee, which is just a very basic Hello World resource. So I include, besides the coffee resource, also a health check here that actually Kubernetes uses with this readiness probe, and then this works. So of course that is somewhat boring. So if I deploy a new version, that's basically what we want to do. I also have a second image available tag 2, then I can just deploy by saying deployment, coffee shop, deployment, update this. And now I updated the desired target state of my deployment. I say, oh, actually, I want to have one replica of this new version now, which I'm going to deploy here. And then, well, hopefully this target state is being met. And now I have a new version. I see this just has been deployed. And if I run my curl command again, then it says, well, coffee with some nice coffee mug. All right, great. So this worked. I just deployed a new version. But, well, let's see. What does it tell me about the zero downtime? Let's do this again. And I actually can say, well, please apply this again. Deployment, coffee shop, deployment. And then while this is being deployed, I can say, okay, ask it for the coffee shop. And let's see, get pods. Okay, now the new version is there. And okay, so you saw it was always up and running. I can actually show you what happens. Let's deploy this again. So now we're continuously watching for the status here in this terminal, and then I say kube control apply again, deployment coffee shop, and we will see that actually we will get a new pod, and the pod is now running, but it's not ready yet, which is told by the liveness probe. But this Quarkus application is actually very fast in starting up. Now it's ready, and now the old one is being taken out of service. So that's good. First of all, that's one of the zero downtime features, one of the production grade features, to just make sure that it supports these rolling update deployments, and also that the load balancing of our service works. So our coffee shop service will just forward to one of the running instances on which we now had two at for a very short amount of time. And then this works. Okay, great. But let's see if we can actually trust that zero downtime, if it's actually zero downtime. And for that matter, what I have a testing tool, a load test tool that is called Fortio, and that I can run within my cluster. So what I do in this case, I have a load test scenario where I have a testing tool called Fortio that runs inside my cluster and accesses my coffee shop via the ingress. Why? Well, because I just want to not have too much traffic from the outside of the cluster, because now I want to fire up actually many thousand requests to just make sure that there's actually not a single request that will be lost while I do my deployment. So now I just want to test this a little bit more properly, rather than just with a few command line curl commands. So now I just ran this for a bunch of seconds, and this is my desired outcome. I say, well, 100% of my requests, I have 10,000 here, should be 200 OK, should be successful. Okay, that is good, but it's also somewhat expected because my application just, kept running the whole time. I didn't actually do a deployment. So now let's deploy something here, and I can say now please use the version 1 again, roll this back, and apply this, right? So I can say kube control get pods. I want to just see my pods again, and I want to apply the new version, and I want to fire up my load test. So now I can again watch what happens. I will get a new version, and once that is ready, my parse non-OK code 502. So that is not OK. That is actually, let's see what happened here. So apparently my load test now just fired some errors, and as you can see, not for many, but just a few of my requests, it was actually not successful, and I got a code 502 and not 200. So while you could argue that's actually, not that much of an impact, so most of them went through, but since this is a planned disruption, we actually, should not do this, right? It should not have a disruption for our users, at least if we use such an approach of a rolling update deployment. Okay, but first of all, what happened here? What is the case? What is the reason for this? If we have a look at what happens under the hood in Kubernetes, we can look at following. We have our targets pod, our instance, our coffee shop here, and we have, some pod that accesses our instance via a service, for example. So assuming the Fortio would directly use a service, such as via DNS or service virtual IP, What happens to service? It is basically IP table routing. So it uses some Linux routing black magic to make sure that the request will actually end up at one of our instances. It uses some IP addresses and virtual IP addresses, and these routing logic rules are injected by the kube proxy that runs on each and every node of our cluster. And the kube proxy basically tries to, well, make sure that everything is being reflected what is there in a so-called endpoints object. The endpoints object just is a list of all of the instances that we have for a specific service, so our coffee shop instances. And once that is updated, well, then we have some changes here. The proxy watches for these changes and then makes sure that the new configuration is being reflected. Now, this is the keyword here, watches. So this means it is done in an asynchronous way. Why? Because we have our cluster, which is a distributed system, and all of these updates happen in this asynchronous way, and then eventually this will be updated, which happens in a very short time, but nobody guarantees us that actually some IP table rules will be updated before, while a rule will be updated actually before the old pod is taken out of traffic. So this means that if our pod is already being shut down and doesn't accept any new requests, then we might end up, well, without a proper gateway here, bad gateway. So this is basically what happens here. So how can we look at it from an Nginx perspective? So actually we use an Nginx ingress that works a little bit differently. The Nginx ingress doesn't go to the service directly. It has its own list of pods, but it does a very similar thing. It watches for the endpoints, which have these updates, and then it updates the IP addresses of the pods, which in this case is, same outcome, which also will result in the outcome that we just saw. So how can we mitigate that? We can apply a trick and say, well, we use the pod and we emit a status that once we want to shut down a pod, that we say, okay, the pod is not ready anymore, so please do not route some traffic from the service or from an ingress to it. While at the same time, it's also called lameduck, while at the same time it's actually still working somewhat. So if a request ends up at that pod, it will still be handled, but we're not planning to route some requests there anymore, and in a few seconds it will be taken out of traffic. How we can do that, there's actually a trick what we can apply within our deployment. We can say, well, basically check out the lifecycle and add some pre-stop lifecycle hook. What we can do, we can say, well, have some exec command that we execute as part of this. And in this case, what I want to have, for example, bin sh sleep. What I want to do, I just want to sleep for 10 seconds. So this command will be executed in a synchronous way. In other words, it will be waited until my pod is actually being stopped. So what happens once I get the stop signal is to say, okay, wait a second, before you actually do this, please execute this command in a synchronous way, while at the same time the status is already being updated to not ready. That means that now my pod is actually not ready anymore. I don't want to route some new traffic on it, but if there's still a single or two requests incoming into that pod, because they were just within that time frame, then they will still be handled. All right, now let me just update this deployment coffee shop. And then afterwards, we can do the actual deployment to say, okay, let's change the version again from 1 to 2. And now we see that this change is being updated. And now I can update to the actual version upgrade once my old pod is being terminated. And then I start my load test again, of course, and just hope and see that everything works as expected here. And that we can then just see that we have the desired outcome with all of these requests working as expected. Now actually you can see that my pod here stays in this status for 10 seconds until it is actually being taken out of traffic. And now good news, we have that desired outcome of 100% of the requests that actually worked. So that is one way, a somewhat trick if you want, to just tell Kubernetes, okay, just gracefully shut it down, wait a little bit until everything just went in order in our cluster, in our distributed system with this asynchronous processes happening, and only then do actually take that pod out of traffic. So a very important takeaway here is to just make sure that we actually test our deployment, which is with an approach that is similar to that we can say, please fire up many requests at the same time, so simulate some production load, because while we are in production, we will have a lot of users accessing our application and not just one or two requests from a command line. But this is now more closer to a production scenario where then we have to test and just make sure what happens while we do our deployment and how to mitigate that we don't lose a single in-flight request. The same is true for all of the other resources that are being involved if we have some database connections and things like that. Now, this is the example for plain Istio with an Nginx ingress that I'm using here. If I use Istio, so instead of plain Kubernetes with Nginx, now with an Istio cluster, it looks a little bit differently. So what is this Istio technology? You probably have heard of this Istio service mesh, which uses some approaches with sidecar containers and, proxies to actually just build a mesh of interconnected microservice deployments where I can add some aspects such as observability, some more control, like I can inject some certificates, and I can also connect and do some advanced traffic management. Why I'm showing you this is because Istio gets more and more traction for real-world applications, and you will actually have to take in a few things into consideration as well. So now what I just showed you, I had a Kubernetes cluster. So actually now I will use a slightly different approach. I say, okay, now I actually will use a different branch with Istio, and I use a different cluster with an Istio cluster, basically an Istio cluster with some Istio installation for my Kubernetes example, which now is empty again. So that cluster is also is managed by the IBM Cloud. And now what I will do, I show you a slightly different example. This is still the same application, so my coffee shop, Hello World, but now I use a more sophisticated approach because I have all of these Istio deployment examples. So I have this routing, and there are a few Istio resources that are called virtual service destination rules. I use an Istio gateway in order to access my cluster. So it works now slightly differently, that I say kube control, give me the IP address of my Istio gateway, and now check for the coffee. And now this has version 1 again, hopefully, once everything is deployed and being rolled out. Let's quickly check the pods. Yes, now it should be here. Yes, coffee. So now this works in an Istio cluster. And basically what it does, it has a very similar thing. It has a deployment here of my coffee shop. I include some more labels, which we will need later. And I include, also readiness probe. I don't include this pre-stop lifecycle trick because I can also tell you right away this would not make a difference. But, first of all, let's try out a deployment. So let's change the version here, and then let's again just try to test and load test our application from our Fortio pod that we have again. And just out of curiosity, I want to display my pods here, and of course now finally do the deployment, the update of my deployment YAML. Please apply this and start my load test. So now I start up a load test of Fortio with even more requests than before, and what I do now, I fire up this load test and see what the outcome is. So once I terminate my application, and now you will already see that right now it doesn't look like there is an error. So it does not happen all the time, which is actually why, we have to take care of, let's try this again, of how we make our tests and, how to shape our test scenarios that we actually see, okay, what is going on. So in this case, I might need to increase the amount of requests even. But okay, now we saw something. Not all the time does it work, and now we actually got a different status code than before. Now it's status code 500. And well, we also saw that it's not okay, so it did not work. It's a slightly different error, and you see, okay, this is just a tiny amount of requests that failed from within 20,000. So it's, well, technically doing the maths and just rounding up the numbers, it's actually 0.0. 0 and so on, so many zeros percent, but it's not actual zero, like physically zero, because we do have some failed requests here, even if they're just a tiny amount of them. So now what happened here? Actually, what happens under the hood in our Istio example, if we have an application like here, that could be a coffee shop or our Fortio pod, if we have a running pod in Istio, it's actually two containers. So not just what I called main container here, which would be the coffee shop or the Fortio, but also a so-called sidecar container, a proxy container that is an Envoy proxy that is being injected by Istio. So we don't need to specify that. That comes there out of the box for enabled Istio namespaces. And what it does, well, it will reroute the traffic so that the main container does not do the connection directly. It basically uses the proxy as a proxy, and then that Envoy proxy will connect elsewhere. And in this case, it also includes some connection-based resiliency. It has some approaches, some outlier detection, and a few other things that just will increase the resiliency. But also it will need to be configured in order to do this advanced traffic management so that the proxy knows where to connect to. And this happens with the Istio pilot plane. So there is a pilot plane component that again watches the Kubernetes API for the changes and for what should be reflected within the configuration, and then will reconfigure these Istio proxies. And well, you already saw watches, so this is a similar issue here. It will do so asynchronously, and then again, no matter what the main container does, well, it's a question how the proxy containers will be configured and reconfigured in order to make sure that we again have real zero downtime, even if it's just a tiny amount of requests that would fail for a very, very short time frame. But in this case, we do want zero downtime, and well, there is no alternative. We really need to make sure that we test this properly and that we don't lose single in-flight requests. Okay, now what can we do here? Well, we can use a different approach to actually make sure that we do this manually, so that we do the deployment manually by using some features of Istio. What I can do here, Istio has some advanced traffic management rules and features that I can use. I can say, for example, I want to have multiple versions, such as multiple subsets of my application. So instead of doing just one pod or one version of an application with a few pods, I have two versions. I now call them V1 or V2, or I could call them A and B, old and new, or whatever, at the same time. So this is now not using the rolling update feature of Kubernetes. It is basically two independent deployments at the same time with slightly different labels. And then with Istio, I can specify, well, where to route to. So I can say in my routing, my destination rule, I already include two subsets. One is called V1, one is called V2. And I say, well, actually use a new version, use a different label. And then I can specify what I actually want to route to. I can say, well, from my gateway, please route to version V1. And also inside the cluster, well, that's now very, very basic. It's straightforward. If you have a routing to coffee shop, to a hostname coffee shop, then route it to coffee shop version V2. Okay, now I could change this, of course. I could say, well, actually, instead of V1, route to V2. And what I need, well, I need a different deployment. So what I can do, I can say deployment coffee shop. I can just apply, well, also a second deployment. And now this is a standalone deployment. It's not the same with rolling update mechanisms. No, it's a totally independent deployment that happens to have the same name or similar name, coffee shop-2. And it also has the app coffee shop, but a different second label, version v2. Of course, the different other version. And then in this case, well, first of all, nothing happens. I still can say, well, curl, and it will give me now again the old version, at least I hope so. If that works, yes. No, that is the new version. Let's see what happens here. Deployment v2 and deployment v1. Oh, I already applied this. I actually want to show this step by step. I could actually, but then you saw that it will work. I could undo the routing again to version v1, and now I see, well, version v1. I could do this again for version v2, and then I see version, well, once I apply it, routing, version, and there seems to be an issue with this network lookup. Let's use my Fortio part here, and now we see version v2. Okay, that is basically what I wanted here. So now what I can do, I can say both of them are deployed, but I don't route to both of them. I can say, well, route, that is the initial outcome, the initial starting point, route to v1. I have only one destination rule. Then I deploy a second version, that was what I had before, and now I can make the switch from v1 to v2 and back. And good news is I can make the switch while I fire up my load test, and I can say, okay, deployment, coffee shop, routing. I can apply this, no changes. Okay, then I can make the changes, apply it again, make the changes back, apply it again, and actually now I'm actually doing the deployment from version 1 to version 2, and you see, well, all of the requests still worked here. I have 100% uptime because that connection change is basically a change of something that keeps running the whole time. So the applications do not shut down until I actually make the switch, and then I can take down the version v1. I can manually do this, so then it's ensured that this works as expected. Okay, now what to do with this approach? I could go ahead and make this manually, like I just did. I can say, if I have a new deployment, then I write a new deployment v2. I deploy this. I wait until it's there and up and running. Then I, of course, set up a new version within my destination rule, a new subset, like I did here, v1, v2. And then I can make the switch, which is the actual deployment, v1 to v2 and back. And then once I gradually, once I fully rolled out, I can then take down the old version because it's actually not used anymore. Okay, now if I do this manually, then this is quite an approach and it's quite error prone. So what I would do, of course, is to include some automation. There are a few ways how to achieve that. There are some templating tools for YAML and for Kubernetes, or I could say, okay, now please apply this step by step and use some scripts, for example, some automation within your continuous delivery approach, where this is then just done in a reliable way. Or I can use some technology that sits on top of it, for example, Flagger. So what Flagger does, it includes actually another approach that is called progressive delivery. Progressive delivery is about, well, progressively doing some delivery, doing some deployment, where I don't want to impact 100% of my users with the change that actually might be faulty. I might have a bug or whatever. It might blow up while I deploy to production, but only a small percentage of the users first, and then gradually, progressively increase that percentage to then see whether still everything works. So I basically just make sure that the what is called blast radius of my change is not that big in the beginning, that I start with a tiny amount of users and then I gradually increase that. by using automation, by using a tool that already implements that for me, so I don't have to write a lot of scripts and check all of this manually. It is then included out of the box. What I use for that, now let me just delete all of these resources again for the coffee shop deployment. And now I apply a different deployment for Flagger. What this does, it's kind of similar, but in this case, I use a Canary object. So this is also called Canary releases, to say I just want to try it out with maybe 5% of the traffic first, and then slowly and gradually increase that number and basically see what happens. So see how my Canary branch reacts and how it basically treats all of the traffic, if I have a lot of errors immediately, or if it just works, and then I can increase that number. I can specify how to do this. For example, how to slowly increase the steps here, and then the thresholds of failed metrics, because it includes some metrics to say what is the error rate. Do I have some errors here? What is the even the request duration? So for example, if my application just responds slower than the old one, then I might also actually roll it back. So this is what happens if there is some error. Then also automatically I say, oh, now that did not go well. I roll back immediately and I leave the old thing untouched. So what I can do, and it also ships, and that's pretty cool, it ships with a dashboard that I want to show you with Grafana. So this is a dashboard for this Canary approach with Flagger, and I can say, okay, please include this. And now what I can do, I can just try to drive more traffic on my cluster that we actually see some things. So for example, I can say, please generate some load here, and then I can also just Canary, just see all of the events that are happening here, and then ultimately I will get my deployment that I have. And now in order to make a new deployment, a new Canary release here, I just change the version again from version 1 to version 2, and then I deploy this here, or basically I apply this deployment of my, not the coffee shop, but the Flagger deployment example, and then ultimately it will detect a new version of my release here, a new revision, and just make sure that this then will be deployed here. And then what it does, it will gradually increase the traffic to this Canary branch by, what it does, it uses these virtual services. So the same thing that I showed you before manually, it will show the one from the coffee shop, and then as you can see, I can include not only one destination but more destinations in my routing here with a percentage-based weight. And I can say not 100% and 0, but now it's actually 5% and 95%. And then I ultimately see that there will be slowly some new traffic being there on the new version. And also, and the cool thing is, it includes this dashboard where I can see how this looks like. So I see in my Canary branch what traffic rate I get here. And then also I would see some potential errors, how the Canary behaves here. And then depending on what the error rate is, Flagger will determine whether or not it should roll back the change or fully roll out the change. But that's basically what it will do. It will just advances this to now 10%, 50%, 20%, and you can see that outcome until it reaches, in my case, 50%, and then it will fully roll out that approach. So this is basically what it does here, how this progressive delivery approach works by, minimizing this blast radius, the impact of my release here, to just gradually roll out everything. In this case, now that is quite interesting. It is very helpful to have this dashboard being included here. So I can just advance all of that stuff quite effectively by including this Flagger technology in my Istio deployment on top of my Istio. And what it does, it uses an automated approach to change these resources. Under the hood, it also uses services, virtual services, deployment. That's all things we know already. It ships with this new resource type Canary. So that's new for us, where we can just specify all of this so that we don't have to write that manually. Otherwise, this is something we would need to configure in a shell script or a thing that we do inside of the continuous delivery server or things like that, where now we use this technology to make that rollout. So that is a very interesting approach as well. And two more things I want to show you. So is what is quite important, actually in general, if we use containers, which is this graceful pod termination, which means once we stop a pod or a container, in our case, we just need to make sure that our container gracefully shuts down as well. So that means, first of all, that it handles this termination signal correctly, which means if we tell the container to stop, it should actually immediately and gradually stop. So this means that this termination signal in Unix is being handled correctly, which we can actually try out quite easily. What we can do, let me now just rebuild my application once again. We can start up a Docker container in order to test that and then try to stop it, and then it should very quickly actually stop, just without any complaints. So if we build this into a temporary Docker image and say, okay, now I want to run this, port 8080 for example, coffee shop temp, what I do, I start up my Quarkus application, which starts up very quickly. And now if I hit Control C, it should shut down immediately. This is what it does, stopped. Some applications might take a second or two while you shut down all the resources, while you close all the connections that you have open, while all of the potential child processes are killed and things like that. So it just is being cleaned up correctly. I can also try this by saying, okay, I now have a container running and I just want to stop that container. Actually, let's give it a name, then it's easier. I say, well, this is being called coffee shop. And now in another terminal, I say, please stop the container, coffee shop. And now similarly, immediately it should stop and shut down, which is the case. Now, if that were not being handled correctly, what happens? Well, actually nothing would happen. And then after that grace period, which in Docker is 10 seconds, in Kubernetes that's 30 seconds out of the box, it will actually say, okay, now I lost the patience, and then Docker kill, just the container will be killed, which is not a very nice approach, because then all of these resources potentially would not be enclosed and we could have resource leaks, and it's just not a good way of practice. Fortunately, we can test this quite easily, that our container just handles these signals correctly. A second thing that we might consider in a Kubernetes workload is what is called a pod disruption budget. These budgets are there to basically make sure that some potential maintenance or cluster work does not disrupt our applications that much. It's basically a budget that specifies how much disruption we can take, or in other words, how many of our instances must be available at, in the minimum. So for example, if we have, you can have a look at the documentation, we can have resources that look similar to that, where we specify, again, similar to a service, a selector, which labels to select. And then we specify, okay, from these instances, we want to have at least 2 being available. So in that case, if I do a command, such as, which is an admin command, such as kubectl drain by orchestration manager, by some ops folks, and whoever manages our cluster, then this kubectl drain command will consider these budgets and actually wait and block until not only is a specific node being evicted, where all of the pods are then scheduled elsewhere, but also we wait until these very pods are actually up and running and ready again, So then, only then, we continue with taking down the node and doing whatever cluster work we want to do, basically to say, okay, now drain the node, make it empty, evict everything. So then we can, for example, do some cluster work. We can upgrade the Kubernetes version of our node and things like that. So in this case, we consider these path disruption budgets, and that is something to consider for production workload, where we can just specify how many instances we need at least being available. And now, as some key takeaways in general, we need to properly verify and test, first of all, how our deployments look like, also from a technical perspective. So that means that we really have a test suite that sees whether all of our deployments actually don't have any downtime and really don't lose any requests in a production-like setting. So not just have a bunch of requests actually simulate a load that is very close to a production load. Actually, you can have a much more complex test scenario than I had with, for example, some cloud scenario where you have a distributed load that is being sent to your application, and then test multiple times how your application and your whole cluster reacts while you do this deployment, while you are on the heavy load. There are a few ways how to mitigate the downtime, like a few approaches and tricks that I showed you. Especially we can use, and this is always somewhat the case if we do zero downtime, we use some approach of gradually doing an update, of gradually doing multiple steps being involved, like the Istio example with the traffic management, in order to make sure that our deployments don't have such of an impact to our users. Of course, we do want to use automation to do that. So especially we don't want to edit files ourselves manually, which can be quite error prone, but use automation for that instead. And in general, we want to be able to roll out gracefully. So the progressive delivery approach that I showed you does a very similar thing to say, I want to gracefully do the rollout here and just make sure that everything doesn't affect our users at once. That, for example, the blast radius is not that big, but that is just done with a graceful way. And another thing that we need to regard is what is called N-1 compatibility, especially when it comes to data and databases. So it is quite easy to say we have a stateless application that just says hello world and doesn't hold any state. But especially once we have some state being involved and the state that also comes in a specific schema, especially with a database schema, then this needs to be regarded because once the schema changes, actually our application might fail, right? And what we need to take into consideration is that always, if we do a zero downtime deployment approach, that we have multiple versions of our applications being deployed at the same time, even if it's just a very, very tiny time frame, even if it's just for 1 second, but the old version or the incompatible version will otherwise fail once we do the database migration. So we really need to take into consideration that we have what is called N-1 compatibility, that our application is compatible with database version N or N plus or minus 1, hence the name, at the same time. So there are a few ways how to do that. You can look up database refactoring, and I will point you to some resources how to do that and how to take that into consideration. It's just a question that we are aware of this once we include something that actually holds state. Now, I hope this was helpful and interesting to watch. Thanks a lot for your attention, and you can get all of the resources by following this first link here, where I will include some pointers how you get some more background information, how to get this code and how to try it out yourself, how to actually get hold to your own Kubernetes cluster with a managed cloud if you want to, and just check that out. If you want, you can follow me and contact me on Twitter if you have some further questions or anything like that. You can check out my book if you like, if you use Enterprise Java or modern approaches such as Jakarta EE and MicroProfile. So I hope that's interesting as well. And thanks a lot for watching, and bye.